Hello everyone. Right now we are going to look at lesson 43 together. We're going to be talking about the least common multiple and also seeing how the least common multiple works when we're dealing with algebraic expressions. So the first question we have is, well, what is the least common multiple and when do we even use that? The least common multiple is used most of the time. You're going to see us using it when we're trying to search for a lowest common denominator. And the question that we asked ourselves when we're looking for the least common multiple is, what is the smallest number that's divisible by all three numbers or two numbers or four numbers or however many numbers you have listed that you're trying to find the least common multiple of? So for example, in number 1 over here, we have 4, 5, and 8. So we have three numbers we're going to look at. So the question is, what is the smallest number divisible by all three of these numbers? And we also want to kind of identify that a multiple in the least common multiple is different than a factor is in the greatest common factor. Students oftentimes get mixed up these two things, the greatest common factor of a number and the least common multiple of a number. So let's look at what the differences might be. So let's just take 10, for example. If I asked you to find the factors of 10, you should list 1, 2, 5, and 10. Okay, there's like a definitive amount. It stops. There's only a certain amount that will qualify, and then there will be no more because you're looking for the numbers that multiply together to give you 10. But the least common multiple, when we're looking for multiples of a number, we're looking for when I multiply 10 times 1 and 10 times 2, what do I get? So it's like skip counting. It's the when you're learning your multiplication facts, you skip count sometimes what the products are. So in the tens, we would say 10, 20, 30, 40, 50, and so on. Those are multiples of 10. It's when you multiply, the numbers will get bigger. It's not the factors of the number. So that's the two biggest differences. I'm going to erase that because I don't want to keep that in my notes because I'm going to have a lot of stuff written down here. Okay, so sometimes it works out that if I just multiply all three of these numbers together, I might get the least common multiple. Sometimes that's not going to be the case. I might be able to use that to get a common denominator, but it might not be the smallest common multiple. Okay, so in this case, if I were to multiply these together, I would get 160. Well, I know that 160 is not the least common multiple of those three numbers. So let's look and see what it actually is. All right, so I'm going to show you a few different methods to finding the LCM. You might find one that you love. You might find one that you hate. You pick the one that you like the most. I'll share with you when I get to the one I like. I'll tell you what my favorite one is. So let's list. We'll make a list to identify the LCM here. And this is traditionally, I think when you very first learn how to use the LCM, this is the method that's typically taught. Alrighty, so I'm going to list the multiples of 4, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and I'm going to stop right there because I'm running out of room. And then for 5, I'm going to go 5, 10, 15, 20, 25, 30, 35, 40. Oop, I might be onto something. I'm going to stop there and see if I get 40 down here. Now, if you have good insight, you're going to already know that 40 is going to end up being listed with 8, but let's just see it happen. So 8, 16, 24, 32, bing, 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 right there it is, 40. So we can see that the least common multiple of 4, 5, and 8 happens to be 40. Okay, so that's one method of finding the LCM. Another method, and this is actually my most favorite way, I'm not sure why, I think I just really enjoy factor trees, but we can find prime factors of 4, 5, and 8, and then by selecting the prime factors that are most occurring, and I'll show you what I mean by that, then we can narrow it down to find the LCM. So let's see what this looks like. All right, so we'll just use this. I left you room here to do your factor tree. So you would have 2 times 2, and that's it for 4. For 5, I'm not even going to write anything here because 5 is actually prime. for 8, we have 2 times 2 times 2. And all 3 of those are prime. So we list our prime factors down here because I want you to be able to see them in a certain way. So let's list down what we discovered. We have 2 times 2, we have 5, and we have 2 times 2 times 2. Okay, now over here to the right, I'm going to write the prime factors, but I want to identify the most occurring primes. So what do I mean by that? Let's focus in here. I'm looking right over here at this set of numbers, 4, 5, and 8. Well, I noticed that 4 has 2 2's in it, but I also noticed that 8 has 3 2's. And since I'm looking for the most occurring primes, I'm going to select the number that has the most 2's. So 8 has 3 2's and 4 only has 2 2's. So I'm going to circle the 2's with the 8. That's the most occurring prime number 2. Okay, and then of course I have a 5 here, and that's the only time it occurs, so I have to pull that out. So my prime factors here are 2 to the 3rd power times 5. And when you make that multiplication, you're going to end up with 8 times 5, which is 40. And that's another way to find the least common multiple. Now here's another set of numbers. We have 18, 81, and 500. Let's use the prime factor tree once again. If you would like to pause the video to see what you come up with, at least to getting your factor trees done, and then come back and see how you did, you can certainly do that, or you can just stay tuned with me. That would be just fine too. So I have 3 times 6 is what I'll choose. You could have chosen 2 times 9. It doesn't really matter. And then 2 times 3. And all 3 of those are prime. 81 is 9 times 9, which is 3 times 3 times 3 times 3. And all 4 of those are prime. And then, of course, for 500, I'll start with a 5 times 100. 5 is prime, but 100 I need to keep going. So I would have 2 times 50, 2 is prime. I'd have 2 times 25, 2 is prime. And I have 5 times 5, and those are prime as well. So I'm going to come down here and I'm going to write those primes, and then we're going to select the most occurring primes. So for 18, we said we have 2 times 3 times 3. For 81, we have 3 times 3 times 3 times 3. And for 500, we have 2 times 2 times 5 times 5 times 5. Okay, now I'm going to look at those numbers and I'm going to box in the numbers that are the most occurring primes. So I see that there's a 2 in 18 and there's 2 2's in 500. So I want to box in where I see it occurring the most amount of times. Let's look at our 3's. I have 2 3's with the number 18, but 81 shows 4 3's. So that is where 3 occurs the most. So I'm going to box in those 3's. And then all that's left are 3 5's right down here. So I'm going to box those in. So let's write our prime factors here. So the prime factors then are 2 to the 2nd power times 3 to the 4th power times 5 to the 3rd power. And of course, if you do your math here, you can use your calculator, but 2 times 2 is 4. 3 to the 4th power would be 81, so 4 times 81 times 5 to the 3rd power, which is 125. If you plunk all that in your calculator, you're going to end up with this very large number, 40,500 as your, whoops, I said LCD. Look at that. That's because the LCM and the LCD are the same, but I should not have written that. I'm looking for the LCM, and I knew that was going to happen. LCM. There we go. Least common multiple. And remember, we most often will see the LCM being used to help us find the lowest common denominator. All right, here's another method. I actually don't use the Venn diagram, but I thought it might be worth it to at least share it. You may love it, you may hate it, but let's at least look at how it works. And if you want to use it, then you'll at least have this tool in your toolbox. So let's go ahead and look at this. We're going to use the same three numbers that we just did in 2B, which were 18, 81, and 500. And I am going to assign each number to each one of its, I'm going to assign one circle to one number. Okay, so I'm going to give 18 is going to represent that circle in the top left. 81 will represent the circle in the top right. And then, of course, the bottom circle will be where 500 will be represented. And below this, let me make this a wee bit smaller. I'm going to write down those three numbers again. Now, we already found the primes in letter B above, so we'll just pull those primes down here. Let's just rewrite them so that they are here with this problem. We have 2 times 3 times 3, 3 times 3 times 3 times 3, and 2 times 2 times 3 times 3 times 3 times 3 times 5 times 5 times 5. Okay, so now, how does this work, we asked ourselves? Well, first of all, I'm going to start with the smallest prime number, and that would be 2. And where do I see 2's? I see a 2 here, and I see 2 2's here. Okay, so I am going to notice that I can pair up this 2 with this 2. So I'm going to put one of those, I'm going to represent those 2's by overlapping them into the 18 and the 500 circle. So that would be this section right up here is where 18, the circle for 18 and the circle for 500 overlap. So in that little spot right there, I'm going to put in there one of those 2's. Okay, I'm not going to write it in both of them because it overlaps and represents just one of those 2's. I also have another 2 here that should be in the 500 alone. Okay, now I'm going to look at my 3's. I notice that I'm going to get a different color here. I notice that I have a 3 here, a 3 here. I'm just going to do it because it's underneath it. A 3 here and a 3 here. So I have 2 3's in 18 that pair up with 2 3's in 81. So that's going to go where the circles overlap for 18 and 81. I'm going to put 2 of those 3's right in there. Okay, now 81 still has another 3. So I'm going to put that in just the 81 circle. And then I'm going to take these, let's see, now we have to look again because I also notice that, hold on one second here. Oh, I see. I could have done this a couple of different ways, actually. Okay, but now I see that what I have, and I'm going to get another color yet. Now I have 2 3's here that I can pair up with these 2 3's. So where the circles overlap for 81 and 500, we're going to put what's common there, and it's those other 3's I've put in green, but I'm only going to put 2 in there. 81 and 500 is over here. Okay, and then 500 has 2 of its own 3's here. So I'm going to put in just the 500 circle, and then also 3 5's. Now remember, we're multiplying these all together now because these are like your prime factors. Okay, it's just another way of sorting them out. So underneath here, we're going to put prime factors, and we're going to list those. So I'm going to grab what I see out of the Venn diagram. So I have 2 2's, right? I've got a 2 here and a 2 here. So I have 2 2's. I have how many 3's? Goodness, I have 1, 2, 3, 4. I think I put too many 3's in here. Let me double check what I did here because I think I did too many 3's. 2 of them, because 2 of them should have been overlapped. Oh, yes, wait a minute. I did. I apologize. Wait a minute. 1, 2, 3, 4. Should only have. Oh, because you know what? What did I do here for 500? Why did I do that? 500, I put too many. You know what? I'm so sorry. I'm going to have to redo 500. I was looking at the wrong line here. Hopefully you're screaming my name and telling me to stop, Mrs. Quigley, because you're listing the wrong factors here. Let's start this part over. I'm so sorry, guys. I have a nice digital pen that erases quickly, and I'm sure that you're looking for an eraser right now. Hopefully you didn't do this in pen. Let me write these down one more time. I'm sorry. My eyeballs picked up numbers from the wrong place. 3, 3, 3, and 3. And 500 is only 2 times 2 times 5 times 5 times 5. I had 3's in there that did not belong. So sorry. Okay, so let's try this again. So I notice I have a 2 here with the 18, and I can pair that up with the 2 and the 500. So I'm going to put 1, 2 where 18 and 500 circles overlap. So that would be right in here. If you look with me, I'm kind of drawing in right there. That's where my circle for 18 and 500 overlap. So anything they have in common, I can poke right in there. So let's put a 2 in there, and that takes care of those 2. I'm going to cross them out. Okay, now I also have some 3's. Well, let's grab this other 2. With 500, there's another 2 down here on the bottom, and it's only, he can't pair up with anybody, so he's just going to go in the 500 circle. Let's look at our 3's. I have 2 3's in 18, and I have 2 3's sitting here with 81 that I can pair up. So 18 and 81 share 2 3's. So where my circles overlap at 18 and 81, I'm going to put 2 3's in there. And then I'm going to cross those off because they're used. 81 still has 2 more 3's that I need to put in just the 81 circle. And then, of course, I see 3 5's over here that are only in the 500 circle. There we go. Now, if I write down my prime factors and I want to multiply them, I should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whew. Okay, good. So I'm going to end up with 2 times 2, right? There's those 2. I have 4 3's times 3 times 3 times 3 times 3 times, and I have 3 5's. 5 times 5 times 5. Okay, and if you do the multiplication here, it's going to turn out exactly the same as it did in 2b. You're going to end up with an LCM, or least common multiple, of 40,500. But it's just another way to sort that information out. Now for number 4, you can use whichever method that you like. If you want to try the Venn diagram, certainly by all means do it. You need 3 circles that overlap just as you see in number 3, because you have 3 numbers here. I'm going to use a factor tree because that's my favorite. So I'm going to use factor trees for all 3 of these numbers. If you want to pause the video and try your way and see if you come up with the same LCM as I do, that would be fine. Or you can stay tuned with me as I work through this. 270 is 9 times 30. And we'll just go ahead and finish out the primes here. It's going to be a little quiet on my end while I do this. 108 is 2 times 54, 6 times 9. And I'm circling all the prime numbers. Now remember, once you do your factor trees to find the LCM, you really need to relist those right down here. So I'm going to relist for 270. I have 3 times 3 times 3 times 2 times 5. And I could have put that in a better order, so I think I'm going to do that. I'm going to move the 2 for the first 3. There we go. For 108, we have 2 2's and 3 3's. And for 630, we have 3 times 3. Oops, I did it again. Let me put 2 first. I have a 2 here. 2 times 3 times 3 times 5 times 7. Okay, so I have all my primes down. So now let's write the prime factors in exponential form once I figure out what they are. So we're going to pair them up, but remember, what we're really looking for, I'm sorry, I don't want to use the term pair them up because that's really what we did for the Venn diagram. But what we're looking for here is what we stated up here, the most occurring primes. So we're looking for 2's because I see they all share 2's, but who has the most? Right here. So wherever you see them most occurring, go ahead and sort those out. How about our 3's? Who's got the most occurring 3's? It looks like up here the 270 does. How about 5's? I see 270 has a 5 and 630 also has a 5. So we can pull either one of those because they both only have 1. And then finally the 7. So what we have here is 2 to the second power times 3 to the third power times 5 times 7. Now if you put that in your calculator, see what you get for your LCM. You're going to have 4 times 27 times 35. You should end up with 3,780. I'm going to put that in my calculator, though, just to make sure. So we have 4 times 27 times 35 is, in fact, 3,780. Okay, so let's go ahead and flip the page on the back side, and you're going to have to make a quick correction. I've corrected it on my end, but on your end, I realize that it is not the way that I meant for it to be typed out. So please make sure that this second term, I think yours says 6 squared, but it should be 6a squared. So please make that change right there. And then we're going to find the LCD of these two algebraic expressions. So the first thing I'm going to do is I'm going to list them right down here, and we're going to list the primes for 16, and then also you're going to break out those variables so that they each would have an exponent of 1. Let me show you what I mean. So 16 breaks down into 2 times 2 times 2 times 2, right? That's like 4 times 4 is 16. I'm going to take A and I'm going to break it out so that I have an exponent of 1 on each one of those. See? You don't really have to put the ones, but in your mind, that's what's, you want to make sure you're just pulling them out and setting them up as single variables. Okay, and we have 1B and we have 2C's. Below that, we're going to go ahead and do the same thing for 6a squared, b squared, c to the third. So I have 2 times 3 times 2a's times 2b's times c times c times c. Okay, now once you have those, we're going to use the same rule of thumb that we talked about before. Where are the most occurring terms? Okay, well, we see the most occurring prime numbers for 2. We start with 2. I notice that the first one has 4 2's and the second term only has 1. So we're going to choose the ones that has the most occurring 2's. Okay, we're going to do the same thing for 3 because I see we have a 3, but that's the only 3, so we'll box that in. Let's look at our variable A. Where does A occur the most? It looks like in the first one it's occurring 3 times, and in the second one it's occurring only twice. So we want to box in those 3 A's. How about B's? Who has the most occurring B's? Well, it looks like the second term does. And how about C's? Looks like the most occurring C's are here. Okay, so there, if I pull all those out and do my multiplication, I will know the least common multiple here. So let's go ahead and pull those out. I'm going to call them prime factors because we know that the 2 and the 3 are prime. I really don't know what the variables are representing as far as a number, but I'm just going to call these prime factors. So we're going to have 2 to the fourth power times 3 times a to the third power times b to the second power times c to the third power. Let's do this math here and we'll have our least common multiple. So 16 times 3 happens to be 48, a to the third, b to the second, c to the third. And that's how you write. Did I make a mistake with my c's? No, okay, I'm all right. Although, I think I have it written down. Yeah, we're okay. All right, so we're good. It needs to be to the third. Okay, I'm sorry, I have to fix something in my notes before I miss it. I want to make sure I have this. I had something written in my notes different than what I actually have typed there. When I made a handwritten change, I wrote down the wrong exponent. So I need to put one more C here. There we go. And that is to the third power. Sorry, guys. I just want to fix it so that I don't forget about it. Okay. And so there you have your least common multiple. Now let's go ahead and try. I'm going to let you do the practice problems for the most part on your own, but I thought it would be good if we did at least one more of the algebraic expressions in searching for the least common multiple. So let's look at C. If you have your books, you can turn to page 174, and this is going to be letter C, which is 4a to the third times b to the fourth, and the other one is 6a to the 10th b squared. Okay, so like we did up here, we're going to break it out into primes and then sort out your variables so that they each have only an exponent of 1. Okay, so 4 breaks into 2 times 2. We have 3 a's and 4 b's. Second term becomes 2 times 3. Oh my goodness, we have to write a 10 times. 5, 6, 7, 8, 9, 10, and 2 b's. Okay, so we can clearly see who's got the most occurring a's, can't we? Okay, so to find our prime factors, we're going to call them. Start with 2. That's our lowest number. Which one of those terms has the most occurring 2's? Find those and box them in. How about 3's? It looks like the second term is the only one that has a 3, so we'll grab that guy. Who has the most occurring a's? Well, that's easy. You can see that. There's 10 a's right here. And who has the most occurring b's? Looks like the first term does because it has 4, and the second term only has 2. So now let's take this and write this out. So we have 2. We can put these to the second power times 3 times a to the 10th power times b to the 4th power. So what is all of that? Your least common multiple is going to be 4 times 3 is 12, a to the 10th, b to the 4th. And that's how you find the least common multiple when you're dealing with algebraic expressions. Okay? Please stay tuned for another video. You can take time to work these out. My recommendation to you guys is just as I said in class. Maybe you want to watch the video now for lesson 44, or maybe you want to do it later, but try not to cram too much math into one sitting. If you can break these lessons out like a couple days apart, I think that's the best way to get these concepts to become solid in your brains. So maybe do 43 on Friday, and then do 44 maybe on Saturday evening, or if you don't want to have the weekend homework, maybe even Sunday evening, or definitely Monday evening. It could be your homework, but try to get it done. It needs to be finished by the time you come to class on Tuesday, and then we'll go over your answers and any questions you may have. All right, guys, thanks for watching.